I'm Anil Kumar, and in this video, we'll develop a relation between velocity, acceleration, and displacement. The topic is rectilinear motion, motion along a straight line. An object moves in a straight line so that its velocity is proportional to the time elapsed. Prove that the velocity can be represented by the relation v square equals to 2as, where v is the velocity and a is a constant. So let's try to understand the question and then we'll derive the given formula. So in this statement, we have velocity is proportional to time elapsed. What does that mean? It really means that if I sketch a graph of velocity and time, let's say, then proportional means directly proportional, right? So the graph should be kind of going through the origin, right? Like this. Let's say something like this. So that's the graph, where the independent variable is time and the dependent variable is velocity. Correct? Now we can write velocity is proportional to time elapsed as v, the velocity, is proportional to t, the time. So that is how we could algebraically represent the given statement. Now whenever you have proportionality sign, you could always write this as some constant times t, right? In the given question, we are given v is the velocity and a is a constant, so I'm using the letter a. So I'm writing at. So a is a constant, so velocity equals to at. Now in physics, this a has great significance. Now before I even move forward, let me give you that significance also. Now from this graph itself, you could think a, the constant, is rate of change of velocity, right? So a could be found as equals to change in velocity over change in time, right? So that is how you get the constant for direct relations, correct? And in this particular case, if you see, rate of change of velocity is acceleration. Do you see that? So a is a very important letter, and it really means is acceleration for us, right? So it has a physical significance. A is treated as acceleration. Okay. So that is the significance of A. So let's move forward from here, and this is a very important relation which I like to highlight as we move forward. Now at this point, I can have two different approaches. One, we could find displacement from the graph itself using area of triangle, right? So if you know, in this particular graph, if the question is find the distance or displacement, find displacement from velocity time graph, what will you do? Since the relation involves displacement, we know displacement basically is area under the curve, right? So displacement is basically area under the curve. So that area itself represents the displacement. Do you see that? So using that information, I can say that S is area under the curve of velocity time graph, right? Now to get a general value, we can consider this time t, and at that time let's consider this as v as our velocity. Then what is the area of this triangle? Area of the triangle is half base times height. Now that means half of base is time t, right? So let me say t, and height is velocity v. Is that okay? Height is velocity v. So the area is half t times v, correct? So what we get here is a relation which says S is equals to half tv, right? Now from here we know that velocity is a times t, right? So we basically need to take away this t from the equation to derive v square is what? Is that okay? So from this relation, I can write what t is. t can be related with velocity over acceleration. If I replace that t by velocity over acceleration, what do I get? I get s is equals to half. I'm writing v as velocity over acceleration, right? Times v. And now if I cross multiply or multiply both sides at 2a, I get 2as equals to v square, correct? If I do both sides by 2a, if I multiply by 2a on both sides, then this left side becomes 2as. Here 2 cancels with half, right? And a with a. And what do we get? We get v square. So we have derived the relation v square equals to 2as. Do you see that? So using area of triangle, we could always derive at this relation. Now in the next video, I'll derive the same relation using calculus. I hope that helps. So you can connect these two and understand what we are talking about. I'm Anil Kumar and I hope that helps. You can always share and subscribe to my videos. Thank you and all the best.